Okay, today's lesson, Geometry Semester 1, 5.81, the study of the area and sectors. So let's go. So in today's lesson, we're going to find the area of a circle and sectors of a circle. So you may be wondering, what is the area of a circle? So let me tell you. The area of a circle is the amount of space enclosed by a circle. Okay, it's the amount of space a circle covers. So if you want to know, for example, if you are trying to figure out the area of a floor and it's in the shape of a circle, you want to see how much dancing room you got. That's when you need to know the area. So let's talk about some things that's familiar. Right here we have making mental images. So for a parallelogram, which you study, the area of a parallelogram is just the base times the height. So right here, area is base times height. So for a circle, if we kind of decompose the circle, the height of the parallelogram will actually represent the radius of the circle. So let's go ahead on and get that written in. R-A-D-I-U-S. So that's what goes right here on this line. The height of the parallelogram represents the radius of the circle. The length of the base of the parallelogram is half the circumference of the circle. So that's what goes on our next line. Let's get that. Circumference. Boom. Of the circle. And that makes the area equal to pi times the radius, which is our base, and our height was the radius. So what you see right below that is the area equation for a circle is just the circle. Whoops, I don't know what that was. Let me try to redo that a little bit. That's my little star. All right, so that's going to be important. It's on your formula chart. The area is equal to pi times the radius squared, where A in the equation represents the area. R is going to stand for the radius. And earlier I told you to use the pi symbol on the calculator, but what I found is that with this lesson, they actually want you to use 3.14 or 3 1400ths for pi. So that's what you're going to use every single time when you have to use the pi button. Let's put it in practice. So here I am explaining how to use the circle area formula. So the area equation is pi times the radius squared. So right here, our radius on this equation is 4. So where I see the R, that's where I'm going to plug in 4. So area is going to equal pi 4 squared. And when I simplify 4 squared, or you can put it in your calculator just as you see it. But don't forget to use 3.14 times 4 squared, which is 16. Your final answer for this one is going to be 50.24. Now, I know you may not have room on your paper to write all of this. Just write it on a side. They got a whole lot of steps on the next sheet, which I think are irrelevant, so I'm actually going to skip that. Look at it. And we're going to fast forward to the pizza problem that's actually in the book. So what is it that you want to know? You want to figure out which pizza is a better deal. So most of the time when you talk about area with circles, they're going to bring up pizza because that's something that people tend to understand. We all understand food. Okay, so which pizza is going to be the better deal? Both pizzas have the shape of a circle. Someone's at the door. Let me go get the door. Okay, so both pieces have the shape of a circle. The size of each pizza is its diameter. So let's go ahead and get that typed in. Diameter. And a 12-inch pizza would cost $8. I'll just write that in. $8. A 16-inch pizza is $12. Okay, so the problem is about comparing the sizes of the two circles. That's the whole gist of the story. So you can use the area Switch to the pen. Formula to solve it. All right. Okay, so use the diameter to find the radius of each pizza, a small pizza with a diameter of 12. If the radius is half of the diameter and the diameter is 12, then our radius is going to be 6 inches. And for the large pizza, if the diameter is 16 and the radius is half the diameter, then at 16, our radius is going to be 8 inches. So then we plug that in. It says use the area formula to find the area of each pizza. So area is pi times the radius squared. We're just going to plug in 6 there and an 8 there. So we got an area here of 113 400ths and 296 hundredths. So then our last step, it says use the area to find each piece's cost per square inch. So when you see the word per, know that you're going to be dividing. So what we're actually going to divide is our value we have here, our area, by the cost of the pizza. So here we're going to have, so the cost of my diameter of, well, my small pizza is actually $6. So 6 divided by 113 400ths is 7 cents per square inch. And my large pizza, that costs, what was it? Did I miss it? I sure did. Okay, this one right here was 12. Let me fix this right quick. That one should be 8. I'm on 2 different pages. All right, so let's see what we can conclude. Okay, so what we can conclude is that the large pizza costs less per square inch than the smaller pizza. Let's go ahead and get that typed in there. Large is less than the small one. Okay, so the large pizza is actually going to be your better deal. I actually do a similar math when I'm trying to figure out the cost of things in the grocery store. We can talk about that if you got a question. Boom. There we go. So this one here, this word, a sector, is a region inside a circle bounded by a central angle and its intercepted arc. So the central angles will not go away. You're going to see those quite a bit. And intercepted, whoops, arc, A-R-C. Put it where it can be seen. There we go. All right, think about a central angle as your slice of pizza and the arc being the crust that go with the pizza. How about that? Okay, so right now we're going to make a mental picture. It says fill in the blanks, then use the mental image to draw a shade. Draw and shade a sector on a circle. So a whole circle, I just gave that one away. A whole circle is like a whole round pizza. And the sector is like a slice of pizza. I'm repeating myself, but it's all good. So if I was to draw this in, and you can't talk about my drawing unless yours is better. This whole thing right here will represent the area of the pizza or the area of a circle. And then the sector would be like about that right there. That could be a sector because it's just a piece. And of course the arc would be the crust. Okay. All right, here we go with an example. So it says fill in the blanks in the example, then use the examples to complete the conclusion. So here we go. We're going to start over here where the sector covers a half of the circle. And we know that the area of the circle is 10 inches squared. And the sector covers, just said it right there in the directions, half of the circle area. Okay, so half of, let me see what I put right there. Half of 10, because 10 is going to be my area, is going to be 5 inches squared. So that means that this area right here in gray, or in this case it could be the white area, is actually 5 inches squared. Okay, so then our next example over here where it says the sector covers a fourth of the circle and the area once again is 10 inches squared. This area covers a fourth of the circle's area of the sector, so a fourth of the 10 inches squared is going to be 2.5 inches squared. So this little space right here in gray is 2.5 inches squared. Okay. The sector area formula works very similar to the arc length formula. So the area of the sector is the measure of the arc length divided by 360 times pi radius squared. So the measure of the arc length AB over 360 is equal to a fraction of the circle covered by the sector. So pi r squared just represents the area of the circle. Boom, 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 boom. All right. So this next part is going to take you through how to use the sector area formula of a circle. So step 1 says to use the given radius or diameter to find the area of the circle, and remember to use pi, or 3.14 for pi. So the area is pi radius squared, and so our radius is given right here is going to be 8. So 3.14 times 8 squared is 296 hundredths. Step 2 says use the given arc measure to find what fraction of the circle the sector covers. So here we go. Right in here, you see that the angle, or the central angle, or the arc length, is going to be 60 degrees. So it's 60 over 360. And so since 60 over 360 reduces to 5/6, 5/6 of the circle area of its multiply is 200.96. So then we just multiply those two and you'll get 167 and 47 hundredths. All right. And so here's the thing. I kind of like to be consistent. So I'm going to tell you how I would do it. I would use what we already know when setting up a proportion. We normally write the part of the circle over the whole thing. And I would set that equal to the part of the circle over the whole thing. And I would set up a proportion. So looking at, like we did before, the left side can be the angle measures, kind of like in degrees, or in degrees. And then this side over here, the right side, you can let that side be the area side of the equation. So let me just write area. Whoops, need the other pen. Area. All right. Side of the equation. So let's plug some things in. No matter what, the whole degree measure going all the way around is always going to be 360. So we'll put 360 in the denominator, and on top, I know my sector area right here is 120 degrees. And I don't know what this part of the sector is, so I call it X, and I put it over the radius, or the area, which is pi times 10 squared. And proportions, I think, are a little bit easier. All you have to do is cross multiply. So I'll give you the easy side. 360 times x is 360x. And then 120 times pi 10 squared right there should give you, let's see, 37,680. And then the last step with solving a proportion is just to go ahead and divide both sides by the coefficient with x. So in this case it's 360. So the sector area here is 100. So the sector area is 104 and 67 hundredths. All right, for the next example, we're going to do it the exact same way. So we're going to focus on the angle side. And my sector here is a little bit smaller. So it's going to be 60, and the whole thing for a circle all the way around is 360. And then over here, I don't know what the area is of that slice or of that sector. So I call it X. And down at the bottom, the whole thing is the whole area. So it's going to be pi. My radius is 13. So it'd be pi 13 squared. Now, the next step you want to do, go ahead, cross multiply 360 times x, 360x, and 60 times pi 13 squared equals 31,839.6. And the last step is to just go ahead and divide everything by the coefficient in front of x. So divide everything by 360. What you do on one side, you got to do to the other. So x equals 88.4. There's no units, so I'll just say units squared. And what I mean by units is like inches, feet, yard, that type of thing. So that's your final answer. Go ahead, look at the checkup practice problems. See if you have any questions, and let me know if I can help. Thank you.